little brief understanding of Synetics, some of the projects that we work on, how we work with data and what some of the expectations of it, and just a little bit about some of the tools and data transformation and data governance. So just to mention as well, we were hoping as well to have one of my colleagues, Sean Latch, with us who's one of our talent specialists. Unfortunately, she's ill today, so she couldn't make it, but I will cover a few of the tips that she was going to mention anyway. So a bit about Synetics Solutions then. Like I say, we're local, based in Burslem. We've been going since February 1992 now, so we've been around for a little while. And our primary function is fraud prevention and detection. We work with high street banks, insurers, telecoms companies. We also work with the government as well, our projects for the Home Office and the Cabinet Office. And the sort of organisations like the insurers and so on, we currently have about 70% of the UK insurance market that we cover to provide these solutions to. And a lot of the work that we do is around identifying where people are either fraudulent or potentially fraudulent or subject to fraud if they've been, sort of conned out of money, things like that, where they might be linked to fraud rings. So particularly with the banks and insurance companies, what we have there is a real-time web application which will act as part of the onboarding process. So when somebody's applying, say, an insurance product, you go on the website and you start filling in all your personal details and so on. As you're stepping through that process, page by page, at some point in that process, there will be an API call that comes out to us. It sends us all your details that you've entered so far in there, and then we will match those details against our database of like known fraudsters and anything like suspicious activity and things like that. And we'll also, to a certain extent, use it to validate that you are who you say you are. So obviously, if we've seen that you've applied for multiple different products across different companies, that's a good indication that you're a bona fide person and that you're living at the address and so on that you say you're living at. So that information then is fed back in real time to the company, the insurance company and so on. They will then generally, we don't actually go back and say this person is fraudulent or they're not. What we generally go back with is a risk score. We say that based on the information that's been provided and based on the information that we've already got in our systems, we think there's a good chance that this person might be fraudulent or that we have some concerns about them. And so what will usually happen then is the insurance company will have a fraud investigation team. That team will receive the details of your application, and your risk score is above a certain level, whatever threshold they decide to set. They will then refer it to an investigations team and they'll look a bit more into the actual application and maybe check out a few details. They might contact you directly to confirm a few things, or it may just be that, particularly for insurance companies, they may just consider you a higher risk. And they're not going to turn you away, but you might not get the cheapest insurance rates. They might increase their policy and say, yes, we'll quite happily take the business, but we're not too sure how sort of genuine this person is, so we're going to increase the policies and so on. So that's essentially how it sort of works with the banks and insurance companies and so on. We also, as I said, work with the Home Office and the Cabinet Office. The work we do for the Home Office is managing their immigration database. So with that, there's laws in place now in the UK that means that anybody who's been denied residency in the UK is not allowed to have any bank accounts and so on. So when you go online to open a bank account, every bank has to check against this immigration list to see if the person is a banned person on that list. If they are, the bank is not allowed to give you a bank account. The idea being that it makes it difficult for anybody to exist in sort of normal society if they don't have access to banking measures. So with that one, again, it works on a web service where the banks, when they're opening new accounts, will call out to us to check against this list. If your name's on the list, they will immediately deny you access to an account. If not on the list, then you go through as a good customer. So we do that one for the Home Office. The Cabinet Office is more of the one that I want to talk about. The project we do for them is the National Fraud Initiative, or the NFI. So for that one, every 2 years we run a batch exercise, which involves all the local authorities from around the UK sending us information to feed into a matching exercise. So they will send us things like housing benefits data, disability benefits, claimants and so on, pensions, payroll information for public sector workers. And we ingest all that data and we actually, over the sort of period of weeks, we take it all in, we do a matching exercise against that. And then again, it's identifying fraudulent claimants. So the NFI itself has actually saved over £4 billion of public money that would normally have gone to either fraudulent payments or where there's been errors where payments have been going out and it should have been stopped and it hasn't, and so on. Putting on my right small. Clicker's broken, unfortunately, so I have to remember I'm doing 2 laptops. So the NFI 2024 exercise that we've just done, we started 1st of October to the 8th of November, so a period of about 5 weeks roughly, where we were taking data sets in. We loaded just short of 6,000 data sets in that period. And the data sets that came in, like I say there's payroll, creditors, council tax reduction scheme, so on, taxi drivers, so understand people who've got taxi driving permits and all this sort of stuff. The busiest week, we received 2,300 files in a week. And any files that come in which are good quality, and by that I mean they match the specification that we're expecting. So each data set that's on that list will have a specific format that we're expecting those files to come in. If it all matches that format okay, then we have an auto processor that will pick up those files, and that will actually feed them through an into our database, go through a process on there. If we have any that are not quite at the right standard, right format and so on, we had 11 temporary data processing staff which then looked at those files manually. And that's then looking at the data quality issues, what's made it fail to go through on our auto processor. Now, sometimes they're quite simple, straightforward things. Other times it involves a little bit of back and forth communication with the authority that sent in the file, try and understand what's going on with it. So, this is a quote from almost 20 years ago now. From a chap at Google, who said, the ability to take data, to be able to understand it, to process it, to extract value from it, to visualize it, to communicate it, that's going to be a hugely important skill in the next decade. I might say that was almost 20 years ago that statement was made. Just last year, the chief of Microsoft said, data is the lifeblood of every organisation. Who can harness its power will gain a significant competitive advantage. That just shows how important this subject is, that for 20 years it's been a key subject. So these companies, the biggest companies in the world, biggest IT companies in the world, have not been focused on software products, hardware products. What they've actually been focused on is how they can extract value from data. And so that's the most important sort of subject really in the IT industry. So you graduate from university, you get your first job offer, and there are certain assumptions that employers make about you. So you know how to use a computer, you know what keyboard and mouse skills are, so on. You understand why computers are better at doing certain tasks than human beings are. But there's the other one that very rarely gets mentioned in interviews, and that's that you understand data. And that's hopefully what we're going to look at today. So at some point when you go into the IT industry, somebody's going to come to you with a task which will involve data, and it's likely going to be something like this: take a data file, extract names and addresses from it and so on, importing it into a database, check if any of them are existing customers. It's a fairly straightforward request. But when you've never actually done that before, it's quite daunting. So you've gone through, you've done all the theory, you've done the training, you've looked at all the sample data sets and so on. So you might think, yeah, okay, I know what I'm doing with this now. I'll crack on with it. Now, when you get to look at the data, this is the sort of problem you start coming across. So there can be problems, export errors, so where the data's come out of another system before it's been sent to you. Import errors, where you've had the data presented to you, but there's been problems with it somewhere along the lines. All sorts of formatting issues you can get, so date formatting, number formatting, address formatting, and so on. Standardisation issues, where there's certain fields that are expected in a specific format. So like national insurance numbers should always be 9-digit long. Driving license numbers have to be in a certain sequence. Telephone numbers, 11 digits, and so on. So there's all these sort of things, sort codes where they have hyphens within the numbers. Making sure that all of that is consistent throughout the data set is one of the challenges that you have to work with. So with the NFI again, some of the data sources that we have to work with, and got there things like blue badge holders, deferred pension schemes, occupational pensions, payroll, personal alcohol licenses, so individuals that have got licenses to sell alcohol, housing waiting lists and so on, student loans, that's on there as well. All that data we take in. The data is ingested from multiple different systems, so it's not just a case of somebody has to click a button and send us a file. Quite often there's multiple systems that hold this data, and it has to be all joined together to be ingested into our system. So that in itself can be problematic. Most systems nowadays support exporting data as CSV format, so that's comma separated values. Years ago, when we were doing this exercise, data used to come in all sorts of formats. We'd have floppy disks, tapes, CD-ROMs, all sorts of things. We even had, on one occasion, there was some Home Office data that was sent to us by armed guard. We actually had 2 blacked out Range Rovers pull up outside the office, and a load of guards get out, one guy with a briefcase handcuffed to his wrist, and walked into the office, and then watched over while our IT engineers loaded this data onto our system, and had to sign a form for it, and off it went again. So obviously nowadays that sort of thing is much easier, and that we can just upload it over the internet. And as I say, the vast majority of the time, that data will come into us in a CSV format. Sometimes we get some in Excel files, which we can strip out, but mostly it's CSV. So, some common data issues. So on first glance, there doesn't seem to be an awful lot wrong with that. You've just got a set of names and reference numbers. But when we start to look at it a bit more closely, and then you can see, like on this one, all these reference numbers down here start with the number 8, but that one starts with a B for some reason. And then what appears to be the name Lorna, which has got a number 4 on the end of it. So that one is quite commonly put down to where you've got image recognition, OCR, optical character recognition. So it's less common nowadays, although there are more applications now that allow you to paste images into it, and then you can extract text from an image. Microsoft OneNote's one of those, really handy tool if you ever need to do that. Paste your image into the document and right-click it, and it'll say extract text. But obviously, when reading text documents from an image, it's obviously prone to making sure that it recognises the distinct edges of the pixels and so on. And sometimes it can throw up anomalies like that. Also, I find that sort of issue more so with archive data. So years ago, there were some big moves to take things like library documents and all this kind of thing, scan it in, and make it digitised so it's easily accessible. And so that sort of thing used to happen quite commonly. So if you're ever asked to work with any archive data, there's a good chance you could still come across those sort of errors where it's just not recognised the characters correctly. This one, names, quite often you'll see names where they're not quite spelled as you would expect them to be. But you have to be careful with that one because sometimes people do have strange spellings of what you might think of a common name. And so instances like that, you just have to be a bit careful of. Don't go around just editing the names, putting it how you think it should be spelled. We did once have a client who asked us to standardise names in a data set where they were taking, wherever we see the name John, can we change it to Jonathan? And we said, well, no, because that might not be what the person was actually registered as. So we had to push back on that one. But yeah, sometimes people don't quite get that and they don't realise the importance of maintaining the original data on it. Sometimes, depending on the systems that people are using, like to make sure that their post-nominals are retained, and if there isn't any option for it on the input form, they'll quite often tag it onto surnames and things like that. So when it comes to the processing side of that, it can be quite difficult to identify. Yes, you can look for like MBE, OBE, and so on, and try and extract those. But sometimes it can be quite hard, particularly if you're just looking for those characters on their own. It could be inside the name somewhere, and so you don't want to be just stripping things out willy-nilly. You need to be able to identify the number of records affected and see what's happening with those. Other thing there, it just says middle name duplicate record, which I doubt is actually somebody's middle name. But what also tends to happen, and again, this happens an awful lot in legacy systems and particularly in public sector organisations where they're using multiple different systems to record information. Sometimes they don't have easy ways of labelling the data in the way they want to. And so what the end users tend to do is they'll find a field in the required data that's not being used very much, and they say, actually, we can just label duplicate record in the middle name field because nobody's going to be bothered if we drop the middle name out, and then that way we can search for duplicate record and we'll be able to identify the ones that we've labelled in that way. And they can get all sorts of labels in there, and that can be really difficult to find in your data because they could literally write anything in there and you've no idea whether it's correct as a name or whatever field it is that they've made use of. So again, with stuff like that, it's making sure that you actually understand what the data is that's coming in and some of the possible issues with it. Like I say, the local councils tend to work with multiple different systems, so there's quite often lots of anomalies in the data when it comes in. Next one to look at is dates. Again, look fairly innocuous to begin with, but when you start to look at them, you can see we've got lots of different types there. So you've got UK date format, where it's day, month, year. And then the next few down are in US format, like that one. We've got some there like timestamps, system timestamps, that kind of thing. And then the bottom ones, don't know, that could be US format, it could be UK format. You've no idea of telling that because you can't tell from the values in there which one of the top two it should be. So again, it's making sure that with the data file that you're using, if it's got dates in there, that you actually know upfront what format to expect in it. And if you're coming across differences throughout the file, then there's obviously been some issues where maybe two files have been joined together, one of them with, say, UK format, one of them with US format. And so then we need to understand what. And the timestamp format again tends to be ones that's used where it's been the date's been auto inserted from systems, mainly because with the timestamp format it's actually sortable. If you do an alphabetical sort on a list like that, the dates will drop into the correct date order, whereas the other formats don't. So sometimes that's used purely for sorting purposes. Addresses. So there's no standard way for storing addresses, and multiple systems will have different ways of doing it. Some might have the whole address all in one field. Others contain, I've seen anything up to 7 address fields in some systems. And again, you've got no sort of continuity with that. Sometimes they'll put address line 1 over there, and then they'll sort of leave the other bits blank and just put maybe the county or the town on the last one. Other times they'll leave the blank bits towards the end here, so they'll put like your street address in there and the location on it, and then maybe leave off this one. This row here, you can see we've gone through, put those addresses in, but then we put postcode and address for, and we've actually got a dedicated column for postcode. We've left that one blank and put it into this one instead. And then the last one, again, they put the entire address into address line 1 and just put postcode in the next one. That's quite common to see in data sets where, particularly as I say, where it's come from different systems, there's been different standards of recording the addresses. And so it can be quite difficult to manage that sort of thing when you're working with a file. This one, again, just looking at addresses, on the face of it, doesn't look too much wrong with that one. So you look across here and you've got like an address, name, then postcode. Phone number is now postcode for some reason. When you're working with CSV files, one of the things to watch out for there is looking at that, that's the original CSV file. You've got your headings across the top and then your data items on there. Watch out for extra commas in the data, because that comma has now just introduced another column into that row. And we have actually got a phone number as it's expecting, but because we've only got this number of columns here and we've introduced an extra one there, that phone number's now been shoved off the end and forgotten about. So for those, again, with CSV files, always check is where you've got alignment. This one, it stands out reasonably well, but if you've got a file that's 100,000 rows and you've only got like 2 or 3 of those within the entire file, most of the time you're not going to see that by eye. So usually we'll need to do some actual tools to investigate and check the data before it comes through. So when it comes to looking at your data, beware of Excel. It is actually, I would say, probably one of the top 10 most useful applications ever. The versatility of Microsoft Excel is absolutely amazing. But at the same time, if you're not careful, there's certain things it can do where it's trying to be helpful, but in actual fact, it's actually making things worse for you. So looking at the raw CSV file, the first column on there is account number. First number looks fairly normal. Second one's got 2 leading zeros on it. When you view that in Excel, it gets rid of the leading zeros. Same with phone numbers. That second row there should have a 0 at the beginning of it. It's disappeared. And the other thing it like is large numbers. It tries to put them into scientific format. So it'll have exponential notation that replace your numbers. So unless you're expecting that, what can happen, and we do see it a lot, is people open the file in Excel. When they're going to send the data to us, they'll check to make sure everything's all right. And then they say, oh yeah, you want it in CSV format. So they go into Excel, save as CSV, and that's the output, which includes dropping leading zeros, and the exponential notation is still retained in the CSV file. And that's what we get coming in, which obviously then the data is no good to us at that point. So when you're using Excel, it's great for visualizing data and viewing data, but just be very careful if you're saving anything when you're going to be expected to send it anywhere. So other data inspection tools, you can't beat a good text editor, because with that, they generally don't try and do anything with the file when you open it. They'll also allow you to do very large files. One of the other things with Excel that I didn't mention is it's got a row limit of just over 1 million rows. It's what was it? 1,048,000 rows is the maximum row limit. So again, with Excel, you could open a file to view it and inspect it and say, yeah, I'm ready to send that off to somebody, save it and send it on. And if that was originally, say, 2 million rows and you send it after you save it in Excel, it will now only have half the data in it. So you have to be very careful with stuff like that. But text editors in general can handle a lot more. And there are some text editors that don't even read the whole file into memory in one go as well. So when you're working with very large files where you might have, 300,000-400,000 rows or millions of rows in there, just opening that file up in other applications will probably sort of crashing the machine because of the size of the file itself. Text editors, there are some that will actually stream the file, so it reads it row by row, and then as you scroll through it, it discards the rows that you're not viewing at the moment. So you've got a window on the file that you slide down effectively. And that's very good if you've got large files that you need to inspect rather. Another good thing with text editors, and particularly a lot of the sort of the newer ones nowadays, Notepad++ and so on, and then if you like using on Unix systems or Linux and so on, they support regular expressions. That's a really good way of inspecting your data, because if you are expecting to see something in a specific format, so like your dates and so on, you can put in a regular expression that highlights those, view the file, and as you open the file up in something like Notepad++ and apply that regular expression search to it, it will identify all the rows that match, and any that don't won't be highlighted, and so it makes them stand out. Or if there's a specific formatting that you're looking for, again, use the regular expressions search in the text editor, and that will identify the issues that you're looking for in your data. So really handy, that one. The other useful thing to have in your arsenal of tools is a file comparison tool. There's a few of these on the market. The two I've used previously, Beyond Compare and WinMerge. There's probably two of the more popular ones. But they literally take a file and compare it to another one. You just have a left-hand side window, right-hand side window, load one file into one side, other one into the other one. And you can have it just view the whole file if you want, or you can have it literally highlight all the differences within the files. So again, if somebody sent you some data and you've asked them to make some changes to it, and then they send you another set of data, you can go in, use your file comparison tool, and then just check to see whether the changes have been made as you expected, and without having to go literally through row by row. It'll just highlight them in the scroll point and go straight to where the edits are and make sure that they've been changed correctly. The other one, again, like we said, most of the files that come in are in CSV format. So another useful tool is CSV lint. That one's actually an online tool that you can use. It's better if you can get an offline version of it, because the online one's good for small files, but if you've got very large ones, you need to be able to do it offline. So that takes what we've done is we've written our own toolkits. So we've written some small applications in C# that will just go and inspect and check for certain things. But CSV lint, what that does is checks to make sure that the formatting of the CSV file is correct. So that you've got, if it's like 10 columns, it's making sure it's got the right number of commas across each row. And if you've got extra columns that dropped in for whatever reason, people identify those and let you know about it. Again, with CSV files, you can also help to reduce issues like that by making sure that all your values are actually quoted, so you put quotation marks around the actual value that you're looking at as well. And then that will obviously get rid of any issues with extraneous commas and so on. So when to fix data. So if you've got data coming in that you need to look at, and there's issues with it, data that you own is okay. You can go in and make whatever changes you need to. Obviously, talk to whatever teams are working with you on that data. That's not a problem. The data belongs to somebody else. Can't really do anything with it. You've got to contact the person who sent you the data, because effectively you are at that point becoming a data processor, and you have legal obligations then, particularly if the data itself contains individuals, details of individuals, and so on. So if you're checking the processing data with somebody else, always check with them before altering the data. If you see errors and omissions, you can contact them, confirm what action they want to take. It may be that if it's a simple fix, they might just say, yeah, we appreciate what's going on there. We know why that's happened. Just go in and change it. So date formats and so on. Yeah, it shouldn't come through with US date formats. It's only one column that's affected. All the dates in that column are the same format. So yes, just convert them. And you can do that. In most cases, though, particularly if there's multiple issues with it, what you would actually ask them to do is resupply the file to you, get them to correct the problems. It's their data, the onus is on them to make sure that it gets correctly done. Be aware of GDPR again, like I say, there are legal obligations around what you can and can't do, particularly with personal data, how long you can retain it, store it, and so on. The standard data retention period is 2 years, but because of the nature of the business we do at Synaptics, if we've identified fraud in a specific data set, we can actually retain that data for up to 7 years, and that's mainly to aid in investigations, because quite often criminal investigations and so on can go on for quite a period of time beyond the normal sort of 2-year cut-off period under GDPR. So we are actually classified as a specified anti-fraud organisation, and so by doing that, we're actually allowed under the law to process and hang on to data for longer than is necessary. There's only probably about a dozen organisations in the UK that have that sort of dispensation, and we're one of those. So the golden rule: never edit the source. When you get a file in that needs working on, or you've been given a database table with some information in it, whatever that you need to do some work with, never edit the source data. Always take a copy of it and work from that. The main reasons for that is you can always revert back to the start. Whatever you do to the processing and so on, if you start making issues with it itself, introducing problems, you've always got the original starting point then to go back to. So always keep a copy of the source data. It also allows you to do a retrospective analysis as well, so you can look at if there's been issues identified in the results that you've put out. You can always go back to the source file and just double check, is that really what they sent to us, or is the issue something that we caused in actually working on the file. So cleansing and enhancement now. So once you've got some good data, what you can do then is move on to what's known generally as bureau services. The reason it's called that is years ago, like I say, before the sort of the ease of uploading things over the internet, companies that needed to update data sets quite often sent them off to what was known as a data bureau. So it would be sending maybe a mailing list. It might be a marketing company who need to send out mail shots to people. What they would do is send their mailing list off to one of these bureau companies. The bureau company would then clean all the addresses and things like that, make sure it was all good, and then send it back to them. And so cleansing and enhancement generally referred to as like bureau services. So it also involves, like, if you've got other data sources, you might be taking your original source data and then enhancing it with other information. So you might take some information from one database or from another one, and then you generally append it onto the end of your data set, where it might be some flags with certain info, or you might be bringing back specific values and so on. In terms of data cleansing as well, the undead don't exist, but you may find a lot of that in your data if you're going to be sending out, like say, mail shots or things like that, or you're working with NHS data or anything that requires data to be up to date. Unfortunately, people die, and quite often they do not get removed from data sets. And so the ways that you can do that, one of the third-party data sources you can access is the DDRI, Disclosure of Death Registration Information. That comes from the UK registry offices, where they obviously record births, deaths and marriages. That's the most efficient way of finding out about deceased people, is from that data set. But it can be expensive. You can't just get it for free. And so it depends on what you're doing as to whether you can afford to use that one. But there are other methods of getting hold of that data as well. And there's a few different data sources, particularly like NHS data, if you're actually working on NHS stuff at the moment, or the Office for National Statistics also maintains some of that. So it's important to filter out any deceased people from your data sets. Another thing is address cleansing. So with addresses, as I say, there's no sort of standard format for addresses. But if you want to make sure that everything is in one particular format and there's as much population of the fields as possible, one of the sources you can use for that is the post office address file. So that's the one that the Royal Mail actually maintains. and that's all the addresses in the UK. And that'll be obviously the most up-to-date information with, like, you know, new house builds and things like that will all go on there with new posts and things. And also companies like Experian and other sort of reference agencies and so on will be able to do that sort of data cleansing for you. So it also helps to reconcile partial address data. So again, if you've got maybe, you know, house number, street and town, but you don't have postcodes, you can obviously match against this data and they'll say, well, you know, it's pretty obvious that's the address. So there's the postcode that's missing from your data and you can append that. And this again is talking about the data enhancement side of it, where you're taking the original data set, but you're making it better by adding in additional intelligence and so on. And also matching against other address files as well, just gives you confidence that a person is who they say they are and they're at the address that's was expected. Anti-money laundering. Again, if you're a financial organisation, you're working for a financial institution and so on, there are certain rules and regulations around how you can do business. One of those is around politically exposed persons. So this is anybody in public office or with a close relationship with someone in public office. They're at risk of bribery or corruption, and so you have to be very careful if you're offering financial products or anything like that to people like that. There is a legal requirement to screen your customer base to check whether any of those people exist in it. Also, financial sanctions. So HM Treasury keep a list of people and organisations that are not allowed to participate in certain financial activities. So it may be they've been identified as funding terrorism or things like that, or they've got links to a country of concern. And so again, when you're looking at providing financial products to anybody, you have to make sure that they're not on a financial sanctions list as well. So just gives an indication of some of the additional data sets that you could potentially use to either check against or enhance your data. Moving on a little bit now to sort of data transformation. So we talked a little bit before about when you're expecting files in a certain format. Quite often what will happen is you'll have a data specification, something similar to that one. That particular specification on there is one that's used in the National Fraud Initiative. That one's for waiting lists. So local councils, their housing stock, if there's somebody who needs to go onto a waiting list, actually all the information that they will need in order to put you on that waiting list, your reference number, name and address, property reference numbers if you've been allocated to a property and so on, date of birth, national insurance and so on, just the general information you need to identify a person, and like when they started their application, when they ended and so on. So again, when it comes to extracting that information in order to send it to us, quite often it comes from different systems. And so it's coming back to these sort of legacy systems where some of them will have the data in certain formats. We say what format we expect it to be, whether it's characters, dates, some might be just integers and so on. So it's important to the person who's actually extracting the data to understand how to convert it and what to expect. So it might be, again, like, for instance, if they're extracting integer values and then expected as characters or character values as integers, making sure there's no formatting issues when the actual data is joined together. So yeah, make sure it's formatted as expected. Special characters and formatting as well. Again, like say where you're converting potentially something that's in a different format, so bank sort codes and so on, making sure that they retain the hyphens and that sort of thing. And then one of the sort of final parts now to look at is data governance. So if you are processing anything with personally identifiable information in it, there are rules and regulations relating to that. And personally identifiable information, or PII, is generally those sort of things there. That's not an exhaustive list. There are other things that can use. It usually refers to any combination of, or any data item or combination of data items that can be used to uniquely identify an individual. So if your data contains any of that sort of thing, then there is legislation around what you can and can't do with it. So that's governed in the UK by the Data Protection Act and GDPR. So anyone using that data must ensure that the information is used fairly, lawfully and transparently, used for the specified explicit purposes. So you'll often see when you sign up to things online, there'll be terms and conditions, or there'll be a little box, do you agree to us using your data for fraud prevention purposes or that sort of thing. That's effectively what you're doing. At that point, you are giving permission for that data to be used, because the company that's using that data can only use it for that very specific purpose. So if, say, for example, you've signed up online and provided your information in relation to something like this, where you're coming along to an event or something, and it's a specific event, unless you've given that organisation permission to use your data for other purposes, that's the only thing they can use that data for relating to the communications for this event. If they then said, actually, we're going to do something else and we're going to start up this, cafe or something like that, and we think the people who came to that event would be really interested in our cafe, and unless they've actually asked for permission to use that data when they first got the information about the event, you can't do it. That's illegal. If they then start sending you emails and say, "Oh, our new cafe, well, you notice you're interested in this event, we think you'll like our cafe," that's illegal. Can't be done. And so that often is some of the red tape that can hold up some projects if you're working with data as well, making sure that the relevant processing notifications are in place, because you can't proceed without them. So making sure it's used in the way that's adequate, relevant and limited only what is necessary, accurate where necessary and kept up to date. Again, this comes back to things like where you've got a list of people in, making sure that you're screening for deceased people or house movers and things like that, making sure your data stays up to date. Kept for no longer than is necessary. Again, as we mentioned under GDPR, maximum data retention is 2 years, but it can be that if you only need the data from a set of individuals to cover a specific event, after that event is finished and any further communications relating to that event is done, you should get rid of that data because you've got no reason to retain it after that point. And making sure it's handled in a way that ensures appropriate security, including protection against unlawful or unauthorised processing, access, loss, destruction or damage. So that one just comes down to the actual security of the data itself, making sure that whoever's using it or people who are supposed to be using it, who are actually involved in what that process is, and it's not left freely available for others. Make sure it's locked down, password protected, stored in restricted locations, making sure that if people are granted permissions in order to access data, once they no longer need that access, making sure that access is removed. So yeah, coming down back around to the NFI, just a few final stats then on that. So these are stats from actually the 2022 exercise. As I say, it happens every 2 years. So we've just completed the 24 one, but we don't actually have the final stats from it yet. Looking at these, so things like blue badges. So those are highly sought after, particularly in cities. And it's quite common for individuals within a family to manage those badges on behalf of a relative, maybe a sick or ill relative. Somebody else in the family will take care of applying for the badge and all this kind of thing and looking after the general administration of it. Quite often what happens is that the individual who's entitled to it, when they pass away, the family decide to carry on applying for the badge. And because there's a very disjointed system in the councils, just because the organisation, the council have been notified of the person's death elsewhere in another department, doesn't necessarily mean to say that the department issuing the blue badges know about it, and so they may just quite happily keep reissuing the badge, which, as I say, is quite valuable. What can happen then is the family will either carry on using it themselves, or they can just sell the badge on to somebody else who needs priority parking and they're not prepared to pay for it in the proper way. Travel passes, again, similar sort of way, where people are entitled to them for various reasons, but if they're no longer entitled, they've not notified the authority, they just carry on using them. Also, where people move house, so they might be entitled to a travel pass within a certain area, but then they move house and then they just don't bother telling the authority that they moved, so they retain the travel pass and make use of it. So it says there, it's like 225,000 of those were cancelled as a result. Generally, travel passes, don't seem a lot, they're about £17 each, but when you start talking about those kind of numbers, it very quickly adds up. Incorrect claim council tax single person discount. Again, if you're living on property on your own, you can claim 25% discount on your council tax. Quite common for people to just accidentally forget to let the authority know when their partner moves in or things like that, and they're still getting a 25% discount when they're no longer entitled to it. False applications and waiting lists. That's the sort of thing where people put them to a waiting list. Quite commonly, they'll apply in different counties. You're only allowed to be on one waiting list, but they'll quite often apply in neighbouring counties as well. Things like that. Council tax reduction scheme, similarly to the council tax single person discount, there are some discounts applied to council tax for people of certain categories, so people with disabilities or illness and so on, quite often exempt from council tax. And again, so making sure that the authority has been properly notified when they're no longer needed. Housing benefit claimed fraudulently or incorrectly. This is things like not notifying of correct sort of income and so on. And then cases where parents to care homes have been cancelled. So where people are in care homes, the local authority has to pay the care fees for anybody who can't afford it themselves. And what tends to happen is people are passing away and then the care home are not notifying the authority and carrying on claiming the benefits for that individual. And social housing properties, again, where people have fraudulently accessed council houses and so on. It's you know, finding it like subletting them and that sort of thing is strictly prohibited. We also can't allow succession, so where someone in the family who's entitled to the council house dies, the council house only applies to the person on the actual application. If there's somebody else in the family still living in that property at that point, they technically needed to vacate the property. They're not allowed to just carry on living it just because they were there before. So there's lots and lots of things that we've identified as safe, and all that is around the data that we receive from all these different local authorities and so on. So it's quite a huge subject. I've gone on a little bit longer than I intended, but hopefully that's been insightful for you. And like I say, if you need to know any more about it, then and just generally about data skills and stuff like that, then by all means, you can contact me on LinkedIn. So any questions at all? I'm sitting quietly taking it in. Thanks, Charlie.
Just check if we've got any questions online, I think. No think so. I got a question from me. Right. So, I mean, earlier you talked about the different sources of data, but a lot of you talked was quite generic stuff, really. So, in terms of the applications then that you've got, I mean, and you mentioned fraud prevention. So, is what Synectics are doing is taking a lot of data and almost jamming it together? Jamming, it's a technical term. But in terms of amalgamating that data to then come up with a conclusion, I just wonder what the use cases might be.
Yeah, so like I say, particularly in terms of application for finance products and so on, it makes sense to try and identify whether somebody is likely to be fraudulent early in the application journey. It's much easier to prevent somebody opening an account than it is to find out after they've opened it and then trying to get the account closed for whatever reason. So that's one of the main reasons that companies use this sort of thing. And the way it's done is, as you say, it's effectively combining information and intelligence from multiple data sets. We do hold a database, which is our national CIRA database. It's about 700 million rows of active data in there at any one time. And that one is where we've got various bits of intelligence that will indicate towards something being fraudulent and so on. So it might be that we've got an address in there that we've seen linked to multiple frauds. So if somebody completely different name and everything like that applies for a product and they use that address, immediately that's a red flag. Why are they using an address that's previously been linked to fraud? Now, again, like I say, we never actually flag that immediately as a fraud because it could quite easily be that, you know, the previous tenants or owners of the property who were linked to the fraud are no longer at that property. This could be somebody new, so you don't want to immediately deny them access to products. So it will go through to a fraud investigation team then, who will actually look at the details of it, and they'll try establish how long that person's been there, whether there's been other applications and so on, and do a bit of digging into it. And that's the kind of stuff that we hold and how we sort of link it together.
Thank you.
Anybody got any other questions? Yes.
You mentioned about detecting anomalies in the data sets. How do you take care of these anomalies? Is there a particular tool that you use to detect these anomalies?
So,
in the data set?
yeah, we tended to write a few of our own tools really, because you obviously there's certain ones that you come across fairly frequently, so we can identify those. So things like we talked about where a CSV file might have an extra comma in it, so you've got data shift where things move over to one side. Simple way of checking for that is counting the number of commas on each row to make sure it's the same number on every row and so on. And so we've got tools that do that. Also, if there's data that we see that comes in a specific format that's not what we're expecting and it's randomly distributed through a file, we might be able to use like the regular expression checking, where we're programmatically checking through a file to see whether anything is not fitting the expected format and so on. It's 9 times out of 10 it'll be a programmatical function that does it, because when you're talking about hundreds of thousands of rows of data, it's obviously not possible to just scan over it with the naked eye. You'll always do a visual check anyway, because if there's lots of issues, it can be quite easily spotted. But certainly to find some of the more sort of difficult issues, you generally need to have some sort of programmatical approach for it. Good stuff. One thing I will mention, unfortunately, my colleague Sean, who was supposed to be coming, who's our talent acquisition specialist at Snected, unfortunately she's ill today. And one of the things that she wanted to mention was about how you can gain sort of hands-on experience in sort of data skills and so on. And it's about really sort of balancing the practical experience with your academic learning. So what she sort of recommends is look out for temp work in holidays and so on, or placements, that sort of thing. There's organisations called Unitemps, I don't know if you heard about those, but they can find you short-term work for either like weeks, months, whatever, that sort of fits around your studies if you want to do that. But ideally, look for placements where you've got some element of like data processing involved in it, and that will get you access to this sort of thing and trying to understand how you can do that yourself. Yes.
Just to shout out, so we're from the field placement and projects team. So if you haven't engaged with us already, please do reach out to us. We do have a dedicated placement manager. She's currently on maternity leave, so I'm covering undergraduate courses, and Julia is on covering postgraduate courses. So yeah, just email us at inbox and we can talk about what.
And usually local businesses will be talking to the universities anyway to let them know what placements are available when they're coming up. Also check companies' websites as well. They're quite often post student placement positions on there. You can talk direct to the companies then to find out information. Okay. Lovely. Thank you very much. Sorry, one more question.
Yeah. So you highlighted different data skills, right? So I just want to ask, let's say for someone coming into data processing and analytics, they are dealing with finance data, medical data and stuff. Do you really need industry knowledge?
It's more about practical. So what you'll tend to find is, as I mentioned earlier, when you've been working on academic sort of samples of data and so on, they're quite often nice clean data sets. They're already in the format you need. There's very little needs doing to them, things like that. It's about getting the skills of how to transform data and get it into the format that you want, looking for those potential data issues, common errors that crop up on it, which you only tend to see when you see actual real live data coming in. So it doesn't necessarily matter which industry you go. It doesn't have to be finance. It doesn't have to be medical and so on. It's just anywhere where they're using large volumes of data. There was a chap that spoke at one of the Stoke-on-Trent events a few years ago, and I remember him mentioning he was working for Land Rover, I think it was, and he was saying that their new Land Rover Defender had got a data logging system in it, which communicated back to head office and kept sending all these streams of log data. And he was up to, I think he said about 20 gigabytes per day per vehicle of data that gets sent back to Land Rover. So obviously you can imagine just dealing with huge volumes of data, there's going to be all sorts of issues that can be going on with that in terms of like service availabilities and all sorts of things. So it's just ideally getting that hands-on experience with real data is what you need, rather than looking at any specific sort of discipline, as it were. Okay.
So I'm just thinking about interviews. So if you've had any students, you feel students in general, is there anything particularly that they fall down on during the interview stage that they don't maybe explain fully, they don't know articulate skills? Maybe is there anything that you do?
I'd say probably not so much like a common failing at interview, but one of the things that will certainly help is if you can show that you've got some level of knowledge of SQL Server, that kind of thing, because that's the SQL programming language itself is still heavily used in industry, and just being able to have that basic skill of extracting data from like 2 or 3 tables and using joins to get it together, so that you can combine data. That's really useful. So I'd say looking at some of the tools that we've looked at here, you know, things like the regular expressions and things like that, to brush up on some of the actual techniques that are used to manipulate data, and that will always impress in an interview if you can show that you've got something that already.
You mentioned SQL. To what extent do you use Python?
We do use it, but not massively. But that's only our organisation. Some organisations are very heavily influenced and use Python an awful lot. Our databases are all held on SQL Server. With a few on Elasticsearch, but mostly on SQL Server. And so it's because you've already got the query language and everything like that built into it, it's easier to just do the stuff in SQL. But some of our data scientists use Python quite a bit as well, but not as much as SQL. So I would say at the moment, SQL is still quite heavily used in most industries. Yeah, Python is a good second one to know as well. Yeah. Okay. Yes.
So, thank you. In line of that, are you saying SQL is more preferable to Python or any other language?
What I'm saying is in industry, SQL tends to be used more. I think it'll gradually shift, to be honest. I mean, SQL's been around for a long time. It's not like it's going anywhere soon, but it's still heavily used by a lot of organisations. So it's always a good one to know, because you can do, even with a small amount of SQL knowledge, you can do quite a lot with it. Like say, if you understand how to extract data from multiple tables and so on, that in itself is just really useful to know. You don't have to know, you know, expert level SQL or anything like that. Just having the basics of it will be really helpful.
It's more user friendly than
yes.
you have.
Yeah, exactly. Yeah.